In this video, I'm going to be having a look at the Puffer Overflow Challenge from RACTF 2020. The briefing that we're given is quite simple. We just have to connect to a network service and exploit it. We've been given the source that's running on the server, so rather than connecting, I've already downloaded that, and I've got it right here. The one modification that I've made here is to just make it not run if we import it, and that'll be useful later. Before actually starting to have a look at what it does, we can run it. And it just prompts for a name, test, and it greets us back. It doesn't do anything else, or at least it doesn't look to. But if we have a look at what's going on, it's not quite doing it in a normal way. It looks like it's executing some bytecode. That's because it is. And we've got this thing here. What's going on is it creates the bytecode using this function called put_on_stack. And if we look at what that does up here, it generates some really messy bytecode. So let's not look at that for now. And instead, let's look down at the execute bytecode function. Python bytecode normally works with a list of globals and names, but in this case, it looks like it's restricted the list of what we can use to just a few basic functions. So there's not much we can do there, or at least it doesn't look like there is. There actually is, because that's the point of the challenge. So we can have a look at actually what this put_on_stack function is doing using the dis function. So I've made a dummy payload, and this is why I made it not run, so I can import that. This dummy payload just calls that and does demo, and I should have a script here that will set it up, and then it just runs dis on it. So if I run that, let's make the terminal a bit bigger, we can see what's going on. So it's loading the chr function, which will take a number and turn it into a string. Then it loads that number because we've got the numbers loaded into our constants. It calls it, and that just puts the number onto the stack. So in this case, if we look at our payload, D, so it puts the character D onto the stack. The next character is E, so it's loading E, and it puts that onto the stack, and then it uses binary add. So what this looks like is, if I could type, so that's what the put_on_stack function is actually doing. Of course, this is syntax error, so let's hide that. And then when it finishes, we've got a return, which is what allows it to actually be called all the way down here in execute bytecode. And it turns out, if we don't add the return, it's tagged on for us automatically. So we don't have to worry about that. So I've also got a script here, which will import a payload from this file, and then it connects to a network service, sends the payload, and shows the response. So that allows us to, in this case, exploit hello demo. So we've already seen that straight away we're executing some bytecode. Can we make use of this? Yes. So that we're going to have to write some bytecode ourselves. Python bytecode is fairly simple though, so it shouldn't be too hard if I just put that on the side. So this is basically the second demo that I've got. So if I switch it to the second payload, the first thing it does is it loads the third global, which in this case is called globals, and then it's going to call the function. Then it's going to use put_on_stack to put the string built-ins on stack, and then it does this binary subscript thing. So what this actually is in normal Python is globals, calls the function, and then it uses that to do this. And it does, basically it'll get the list of built-ins. So if we actually run this exploit, straight away we can see we've just been able to get the built-ins. And the reason this is important is if we go down to the third payload, we can then load the getAttra function, which is one of the other ones that we've been given access to. And this will allow us to call, and then if we put import on the stack, we can call getAttra. So this is now looking like globals Let's just use copy and paste because it's quicker. But then we're wrapping all that in get attra import. So this should give us access to the import function. And if we update which payload we're using and run it, sure enough, we've got access to import. This is going to be really handy when we go down to payload 4 and we call, missing an indentation there. This indentation is just to make it a bit clearer what's going on. We can get the OS function again using getAttra, and we just get import if we increase the payload. There we go, we've managed to get the OS function. Once we've got OS, we can do pretty much whatever we want. In this case, I'm going to be using the popen function, which is a very easy and quick way to call a shell command and get the response back. And sure enough, if I update it, again, function popen. Then one more payload, we're going to call cat flag.txt. So actually, we could make this just ls if we didn't know where the flag was. And that would list things. But what we're actually getting, if I just clear the terminal and run it again, so we're getting this os.wrapClose. And what we actually need to do is call the .read function. So that's yet another call to get attra. And we just need to call .read, get the attra, and then call read. This return isn't really needed because, as we know, it's tagged on here. But I've just got it there for the sake of it. And then the final payload, in this case, is catflag.txt, and there's the flag. But if we didn't know what we had, we could just put ls, and it would list out all the files. In fact, these are the files you can see here, because that's where it's running. But we've got flag.txt there. ls.la is going to list everything. What we want is catflag.txt. And as we've already seen, it got us the flag. So this is a bit of a mess, but what we can do is actually write it out as normal Python. So if we work from the enum, we've got globals. So far it's looking about the same. We're going to call getAttra on that to get import. Going to call getAttra again to get OS. But I'm going to just switch to a random Python file to get some syntax highlighting. There we go. And then we're going to call getAttra again to get popen. Then I'm going to call that with cat flag.txt. Let me just turn on word wrap. There we go. And then we need to do another call to get attra, to get the read function, and then we're going to call it. This is not very pretty. What it really looks like, if we actually wrote it out, would just be that. This is yeah, okay, whatever. This is our final payload, and it's fairly clear to see why it works, because that's what I'm missing the S. Once we've got access to globals, we can go through the chain. Actually, I've got it down here. This only really works because we've got the numbers 0 through 256 already available for us. If we didn't have those numbers, it'd be a bit harder. It'd still be possible, but not quite so easily. But yeah, that's basically how you do the puffer overflow challenge. And Crown managed to solve it on the second day, I think. So well done to Crown for doing that.